Hello, this is Gia and Jackson with our final project for machine learning. So we created a financial budgeting tool that uses anomaly detection, time series forecasting, and some natural language processing features to help the user plan their budget better. So to do this, we use an isolation forest model, a long short-term memory neural network, and Google's Gemma 2B large language model. And we'll get into all of these as we go through the notebook. So prior to running the notebook, the user would need to follow the steps that are listed here because Google's Gemma LLM is a gated model, which means it requires specific access. So follow these steps. They're really quick, should take just about a minute or two, and you'll be able to run the notebook with no issues. So here we're just going to start by installing some things to allow us to utilize the data set that we have from Kaggle. And next we're going to install TensorFlow and make sure that we have a GPU available. Perfect. So the next thing we're going to do is upload your financial data into the system. And by doing this, you consent to allowing our models to analyze your data. So the first thing that we're going to need is a CSV file that breaks down your transactions by having them have their date, amount, and category. For example, you can say that you were dining out and spent $100 on July 13th of 2004. And we're also going to need your weekly income. So even if you are not paid weekly, try to estimate and average out how much you would make every week and insert that amount here. So for example, we're saying you make about $700 a week. And this kind of just goes through and breaks down the CSV file and ask for the weekly income.
We just pull it up, and that's the CSV file that we'll use.
Perfect. So the next thing we're going to do is, again, install some dependencies that Kaggle will rely on, which is where our initial data set came from. And now here is where we're going to first complete our anomaly detection. So first we're going to just kind of clean up the data and make sure it all aligns perfectly for our isolation forest model. And this goes through and essentially pulls out any anomalous transactions. So they're either really high or really low based on the user's other transactions, and it displays them here. So for example, the user spent $149 on something on April 29th of this year, and this was probably really high for whatever category it belonged to. So we're just going to display that on the screen here as an anomaly for that category.
Yeah. And so once we've done the anomaly detection, really the next step is to think about actually forecasting before we can implement the large language model. But in order to do that, I need to talk to you about what it was and what it is. So what it was a monthly approach. However, there wasn't a lot of data available for the monthly approach, so instead we pivoted to actually something that I think makes more sense, a weekly approach. You can see that the signal, just intuitively, the signal will be much more readable and much more approximable with a weekly data set because we can aggregate it and have more aggregate values. So it's longer, it's more continuous, it's more dense, and we'll train what ends up being a single layer LSTM long short-term memory model on the normalized total spending sequence. And we're going to look back 12 weeks, and we can actually do that repeatedly when we query it to try and predict however many weeks in advance we want. But in order to really do this, we have to first aggregate the data by week, and that's what we do. We're doing this, of course, for the training data set and the test data set first. And so that's what we're doing here. We have to pre-process it as well, similarly to how we did before, things like scaling, and then also actually generating the look-back grouped data. So we're going to group data in groups of 12 automatically. We're going to split 70% training, 15% for our validation and our testing sets. Once that's done, we did tune the hyperparameters a little bit just by thinking about 7 kind of maybe candidate models and just actually kind of testing them on our own here. Now, I won't run the code quite yet, but I'll show you. First of all, you can see we varied the learning rate, we varied the batch size that we train with, what kind of layers we're dealing with, one long short-term memory module or one long short-term memory layer or two, how many units are in there. We varied the look back a little bit. We ended up finding that a look back of 12 made the most sense, which is why we say that earlier. And yeah, so here are some of the learning curves that we generated for that. Just scrolling through these, you can see config 1 kind of is pretty promising. Config 2 is thrown out on the basis of config 1, and config 3 is similar to config 1. 4 is better than all of those, I think. 5, slightly worse than 4. 6 is our most promising model by far. And then you have 7. Now think about this. The graphs actually here are very zoomed in. So all of this variation is, and I want you to keep that in mind when we look at the final results in a second. So this is all very minute variation, but we're trying to pick the best model. So that's what we're going to do. So we found that number 6 was the best. You can see some of our summary and the reasons why we got to that decision here in these tables. So at this point, we're actually going to implement it. And so let's do it. It's really quick to train. Check this out. It's going to take about 20 to 23 epochs to successfully train it. Yeah, 20. Okay, so there we go. Now that we're trained here, I'll show you the learning curves. And the learning curves look like this. You can see similar trend to what we saw earlier. And again, that really zoomed in thing is that these lines are very close together, which is great. And now we'll evaluate on the test set. We've done our tuning. It's time to test. And so you can see our loss was 0.0040 in this instance, which is great. And you can also see with this very zoomed in kind of metric, these lines, the predicted value and the true value look like they're very far off. But you know, since this is mean squared error, they're actually very close together. It's just that we're very zoomed in because of how close the data is. This model is performing excellently, far better than we actually thought it would, by far. And so yeah, at one time, we got it to run with 0.0027, which is like crazy. And it has been actually a very efficient part of our thing that I didn't think was going to be efficient at all. Efficient part of the project. I thought it was going to be many more battles with that thing than I actually had to fight. So that's good. So what we'll do now is we'll predict the weekly expenses to give them to the LLM. And as we give these weekly expenses to the LLM, I will give you Gia to talk a little bit about the LLM. My segues are on point.
Yep. So here I am again. I'm going to talk about the large language model. So for this project, as I mentioned earlier, we utilized Google's Gemma 2 model, which is again a gated model on Hugging Face. So please make sure before you run this notebook that you have followed the instructions at the beginning of the notebook. But our large language model essentially provides a unique custom recommendation based on the financial transactions that were provided above. And it also provides a chatbot feature to allow the user to kind of go back and forth with the model and figure out exactly what kind of recommendation works best for them. So the first thing we're going to do is install some transformers and log into Hugging Face. And this is an essential step because the model is gated, so we have to make sure that we have access to the model. Okay, so I just copied the access token that we received from Hugging Face. So I'm just going to log in, and that confirmed that I have access to the gated model. So the next thing here is kind of going through our LLM code. So I'm just going to give a really quick overview. Here's our initial prompt, because as you'll see in a moment after I run this, we have the LLM generate an initial recommendation based on the transactions that is provided. And something that I really want to point out here is we had to add these 2 lines to our prompt to help prevent some hallucinations, which are when an LLM makes up something either untrue or just kind of unrelated to the result that we're trying to get. So this was kind of generating its own chatbot. It was making up things that the user was saying that we just fully weren't saying. So we had to add these 2 lines, and since then we haven't been having that issue. And again, due to some limitations of Colab, this Google Gemma model is one of the better ones that we were able to access, but in a better situation, we would be able to use something like OpenAI or Claude.
Yeah, Or like even just like Llama GPT,
Yeah.
something that's like bigger, more robust.
Mm-hmm.
Yeah.
So that generates the initial response through here, and then going down here we have our chatbot feature, which is essentially just a big loop until the user inputs exit, and then that means that the loop will stop and the chatbot will stop trying to chat with the user. So here we are, we're going to generate that first initial recommendation that I mentioned earlier. Okay, so our LLM produced this first recommendation. I'm not going to read the whole thing out loud, but it points out that there's a few areas where we can improve our budget. So again, that weekly income that we mentioned earlier, the $700, and we spent around $600 for the week, which is above where we were planning to budget. So this means that we have some wiggle room for flexibility, and it also pulls out those anomalies that we pulled out earlier, the unusual spending patterns. A lot of money has been spent on healthcare. However, that's been pretty consistent. And we've been spending a lot on entertainment and groceries, which has been higher than usual. So it recommends trying to reduce these costs. And it also says that our utilities and miscellaneous categories have had some spikes recently, indicating unexpected bills or increased expenses. So it is trying to keep things as realistic as possible. So here comes the recommendations. Try to be more detailed in tracking our personal spending, trying to reduce spending on entertainment and groceries, trying to find a cheaper alternative or meal planning, trying to figure out an emergency fund, which could be beneficial down the road, and trying to set more realistic financial goals, including paying for vacation or whatever comes up in the future. So I'm going to ask it, how can I reduce my healthcare spending? And we're going to see what it comes up with. Again, this model is not as good as one that we would be able to use were we not using Google Colab, so it might not generate the best recommendation, but we're going to try to get something that's probable and could be realistic in some situations. So for this example, it didn't exactly understand what I meant by health. It thought I meant financial health. So this is one example of the model struggling to understand our request. So I'm going to ask it more about the entertainment category here to see if it'll get a better response. Oop. So here it's asking me, what do I spend the most on when doing entertainment? So I'll say that I go to the movies a lot. Movies are definitely fun, but they can be a bit of a budget buster. It's recommending to use a streaming service or finding another free entertainment option, which could save money down the road. And again, here it's thinking about other anomalous transactions that we could cut back on, not only for entertainment, but just in general. Yeah. So it's saying we're spending around $600 per week on healthcare, which is a lot of money if we are healthy, which is something we never specified, but we could specify if we are or are not healthy, and it'll alter the recommendation based on that. True. And again, we are spending a lot on entertainment and utilities, which I mentioned earlier. So these were just 2 example questions. I'm going to exit the chat for now, and I'm going to kick things off to Jackson to wrap it up.
And I'll mention one more thing about this, actually. I think, did it say, so it said like healthcare is 100, and then it dropped 600 to 700. So here's an example of what we were talking about. We're just not going to be able to eliminate it entirely. We're going to have it kind of hallucinating a bunch. You can even see it start talking in the third person, which is great. I mean, I think it's funny, but it just what it takes is a different model, it takes a better prompt, and it takes searching for or having access to run different large language models that are probably better suited for this task. But that's one of the ways that we can improve it, of course, is the large language model. We talked about that a number of times, right? And so we did, though, successfully implement a suite of 3 machine learning models, and each support financial advising in a unique way, right? So we developed the random forest model that we talked about earlier that's detecting outliers and anomalies in user spending habits. We did the LSTM time series model, right? And then you saw the large language model. And I'd really like to zero in, since we kind of already talked about the LLM and the random forest, the isolation forest just is what it is. I'd like to talk about the time series model a bit, right? So among the models, we do believe that the time series predictor offers the clearest path for further refinement, I think, just because what refinement for the LLM would really be is choose a different LLM. So instead here, what we can do is actually talk a little bit about how to improve this. Right now, we did get a great test MSE, and it did demonstrate strong alignment with general spending trends, right? It predicts smoother values, which makes sense, but it's underreacting in a lot of ways. And this is, of course, maybe due to univariate input, right? Total weekly spending only, right? That's limiting temporal nuance. And say, essentially, it doesn't have enough to inference on in a lot of ways. So how can we solve that? We can engineer, we can give it more features, right? So adding auxiliary features is a great idea, right? So categorical breakdowns to implement categories, do calendar-based indicators. So things like which week it is. So is it week 1, 52, whatever? Is it a holiday week? Like is it Christmas week? What day of the week is it even? You can add that kind of stuff in, right? Things like where is income coming in? What actually is your budget? These kinds of questions we could even have, and that could go to LLM as well, like what is your budget? And even like lag differences, so like having a delta factor that comes from week to week and just understanding the change, right, over time could be interesting as well. Now the model architecture as well could be improved, right? More expressive models could be used. You could use an attention mechanism, right? Even something like a transformer, which we know a lot of that research has been going into NLP, but it is also just as useful for things like time series modeling. Why? Because a transformer, the paper that introduced it is called Attention is All You Need. And so essentially what it is context aware. So if we can take certain things in context and predict based on the context that came before, this is the same kind of thing that's happening here. And a GRU is just, it's kind of similar to an LSTM. The other thing we could do is just make a multivariate LSTM, which is kind of what we were talking about up here with feature engineering. More variables go in there. Even just augmenting the data set a little bit on our own could be great. And even like adding more evaluation metrics to help. So doing like MAE or just trend direction accuracy might even help us to understand things further and give more diagnostic data to the LLM to then report to the user, which could be very interesting. And so these enhancements are going to require a couple of things: more data, right? It's going to require more design, more validation, but they're the most promising directions to build a more responsive and personalized financial forecasting tool, right? So in the world of machine learning, we're never done. Same thing with software engineering, you're never done. So these are the next steps. But yeah, we have a model here, and we have a model that's very promising. And it actually does achieve a lot of what it's trying to achieve. Specifically in the forecasting department, it really does achieve what it's trying to achieve. And a lot of the shortcomings that you saw today were probably from the LLM, and that is more due to the runtime environment than anything else that we have. Thank you so much for your attention and your time, and for a wonderful semester.
Thank you.